Predicting Bitcoin Market Using Text Mining, a CS410 final project by Junhui Sito, Inrui Li, and Sunwoo Kim. The main goal of this project is to explore the correlation between Bitcoin price index and relevant news articles. First, we scrape news articles and then perform sentiment analysis to get the polarity values. Finally, we implemented machine learning techniques for classifying Bitcoin price prediction. The Arizona Financial Text System, AZ FinText, is a quantitative textual financial prediction system. It is a framework of the paper, A Quantitative Stock Prediction System Based on Financial News, which was written by Robert Schumacher and Xin-Chun Chen. This system employs financial text as a primary key in predicting stock price movement. Schumacher and Chen explore various textual representations, such as bag of words, noun phrases, and named entities, to estimate the price of the stock 20 minutes after release of an article, and perform discrete stock price prediction using a synthesis of linguistic, financial, and statistical techniques. They use support vector machine to partition articles by similar industry and sector groupings, and compared the result against quantitative funds and human stock pricing experts. They reached a predicted directional accuracy of 71.18%, and the system gave a trading return of 8.5%. Our goal is to implement a system with a slightly different approach and goal in mind. We wish to simplify the system for users less experienced with financial systems in general, and focus on the cryptocurrency, Bitcoin. Our application will produce results to facilitate decision-making among users by classifying our prediction into three groups, up, roughly constant, and decrease, as we will be mentioning in the following sections. The utilized data are the Bitcoin Price Index, BPI, and relevant news articles to Bitcoins. The numerical data for the BPI were retrieved by using the API from Coindesk.com and specifying the start and end dates of interest. As for the articles, we found main news outlets that were primarily interested in the topic of Bitcoin itself. These were newsbitcoin.com, newsbtc.com, and cryptocoinsnews.com. By employing the Beautiful Soup API to scrape the articles from these websites, we were able to get 770, 3,851, and 4,917 news articles respectively. One difficulty we faced was that the news articles were more challenging to attain due to a lack of APIs to easily use as we did for the Bitcoin price index. Furthermore, another obstacle was that the main search engines such as Google or Yahoo restricted us from mining news articles with much ease. After the data collection, we continue on to estimating the sentiment of the web headlines using the TextBlob API. The sentiment analysis is done by using bag of words approach, where we count the number of positive and negative words in each sentence and assign sentiment from -1 to 1 for each line. For each sentence, we also compute a sentiment polarity score from -1 to 1, where -1 is very negative and 1 is very positive, and a subjectivity score from 0 to 1, where 0 is very objective and 1 is very subjective. One issue we are faced with is that some type of sentences like "this play is not amazing" or "interesting" can be wrongly classified to be positive because it has more number of positive words than negative words. This issue should be improved by using a diagram or deep learning method in the future. Significant test. This estimate aims to show the scattered distribution and a general idea of how price and sentiment are associated. We use linear regression approach to model the relationship between polarity value and price. The regression is done using least square estimation. We derive the fittings function as y equals -11.8x plus 1.21 with a small r-squared value of 0.005. However, the low r-squared doesn't necessarily affect interpretation of significant variables, especially in some fields like finance, where r-squared value is often expected to be low. So we did the t-statistic significance test and found that the slope coefficient is significant at the 5% significance level. This indicates that there can be some possible linearity among the two variables. Price difference is slightly negatively proportional to polarity. After we collected and processed our data, each tuple is identified by the date, and the attributes are the number of news articles published on the three different websites, the mean polarity and subjectivity of the headlines. Each of the data points are labeled with up, down, or roughly constant, denoting whether the price of the Bitcoin is going up, going down, or remaining roughly constant, respectively. We then use machine learning techniques to make prediction of the behavior of the Bitcoin market. Specifically, using the data point from one day, we want to predict the behavior of the market the next day. We first divided data into training set and test set. The training set was used to create the classifier, while the test set was used to evaluate the performance of the classifier. We use a technique called ensemble method in machine learning to predict the class. An ensemble method is a powerful technique to predict the class of a data point by using different models or classifiers. As shown in the figure, each data point is assigned to different classifiers, m sub k, for prediction. Each model or classifier will return a prediction. The predictions are then collected for a final decision. The final decision is made by majority votes. For example, the class that is predicted the most by different classifiers chosen as the final prediction. In our case, each of the classifier in the ensemble method is a decision tree. This type of ensemble is called random forest. The figure here shows an example of decision tree. Each node in the tree is a splitting attribute that separates the dataset. The splitting attribute is selected based on the information gain of each attribute, and the attribute with the highest information gain is the splitting attribute. The node is then branched into several other nodes based on the splitting criteria until it reaches a leaf node, which is the label of the data point. For example, the data point that has more than 30 articles will be further checked for polarity. A data point with more than 30 articles and positive polarity will then be predicted to be in class up, meaning that the Bitcoin market will go up the next day. Using the random forest algorithm, we created our classifier using the training set and evaluated the performance using the test data. We obtained an accuracy of about 70%, which is similar with the results published by the AZ FinTech system. As a product of our research, we have created a web application for simplified visualization of the relevant text and non-textual data relevant to our focus. Our URL is shown in the slide. The main page shows on the left-hand side the two panels, one concerning the prediction for today, and another showing numerical time series Bitcoin price index. On the right-hand side, the time series BPI data can be observed. When we experimented with the data for February 1st, 2016, our application predicted that there will be a slight increase in the BPI, and when compared with the actual data, it matched the predicted behavior as can be seen in the chart. Further visualizations can be seen. The changes in BPI, the number of articles released per day by respective news outlets, the polarity of the news articles from each news outlet, and predicted behavior of the BPI is also available for users to see. Through the visualization of data, one can observe the overall picture and see the pattern in the line graphs. In conclusion, the main goal of our project was to use text mining to predict the Bitcoin market. The data used were the Bitcoin price index and the news article titles from 3 different websites. And then we performed sentiment analysis and linear regression to check the correlations between Bitcoin price and the polarity. Then we used random forest, a machine learning technique, to predict the behavior. Our accuracy was about 70%, which is very similar to the AZ FinTech system mentioned before. Currently, we have built a website for data visualization, and our future work involves adding more attributes, further improving the model, and implementing time series supervision. Thank you for listening.